Hello everyone, I am Hansraj and I'll be demonstrating how sharding takes place in MongoDB. So to begin with, let's just have a look at our architecture diagram where we see how various components interact with each other. So here I have my Mongo's query router which takes in requests from the application layer, and Mongo's is basically a routing service for MongoDB shard configurations. So these configurations are stored on a config server, and apart from that it also stores metadata about the sharded cluster, so which is then used by Mongo's to identify location of a correct shard to serve a particular request. So additionally I have kept these shards in a replica shards, and as well as the config server in a replica setting, and I have implemented all these nodes as AWS instances. So let's have a look at the AWS instances. So here I have my two config servers, two servers in shard 1 and two in shard 2, and a Mongo's query router here. So all these nodes have their own primary and secondary node. All of these nodes have a security group named Mongo internal, where I have opened ports 27017 to 27019, which are used by Mongo. I have already logged into all of these instances. So the two nodes back here are my config servers, and the four nodes here are my shards, are part of my two shards basically. And here I have my Mongo server. So as shown in the diagram, the config server is listening at port 27019. So this one is my primary node here, and this is my secondary node of config server. Now let's check the shards. So my shards are listening at 27018. Here's the primary of the first shard, and this one is the secondary of my first shard. Similarly, this one is primary for shard 2, and this is secondary for shard 2. And I have my Mongo's listening at port 27017. So let's just check the replica set information. I have a replica set named CNF for my config servers, and as you can see, this particular node here is my primary node, and this particular node here is my secondary node. Similarly, let's check for our individual shards as well. So I have a replica set named SHR1 for my shard 1, and this particular node here is my primary, and this is my secondary node, as you can see here. Similarly, for second shard as well, I have created a replica set named SHR2, and I have my primary node here, and this particular node here is my secondary node. Okay, so I already have created a database named test, where I have a BIOS collection. So let's check the count in my BIOS collection. So it gives me 30. So the Mongo's gives me an aggregate of the total number of aggregate of both the shards, which is 30. So now let's check the individual shards. Let's see the count of documents in my BIOS in shard 1. So I have 15 documents in shard 1. So same will be replicated across its respective secondary node. Okay, 15, and I'll have 15 nodes, 15 documents in shard 2. Okay, and same is the count in secondary node as well. So now what I have done here is I have this sample data here. So I have used a hashed key as my shard key. So I am hashing name.last, and the Mongoose internally hashes it and shards it across two shards. So the reason for using hash key is because there might be a possibility wherein I select a particular field which goes into one particular shard. Majority of the data goes into one particular shard. So to avoid that inconsistency, I have used hash key, which sort of balances out the number of documents in each shards. So I'll just put this sample data in Mongoose. So I've inserted all this data. So now I have total of 40 documents which are distributed across two shards. So now let's check the individual count on each of the shards. Okay, so I got 5 of my additional 10 documents in shard 1, and the same will be there in shard 2 as well. So shard 2 gets 5 of the documents. So my Mongoose gives me an aggregate of both the shards, 20, which is 40. So that's how sharding takes place in MongoDB. So now, having checked how the data is being distributed in shards, so now let's just see what my shard key is. Okay, so yeah, as mentioned earlier, so for the database name test, so I have my shard key name.last, which is in the hashed form. Okay, so we'll see how the data is distributed amongst the shards, see some statistics about it. Okay, so now let's just see how the data is being distributed amongst shards. We'll see some statistics about it. Okay, so as we see, there is 50% of data is in cluster 1, as in shard 1, and 50% of the data is in shard 2. So this is how sharding takes place in MongoDB. Okay, so as part of my WowFactor, I have explored AWS Elastic Beanstalk to deploy a sample web application. So this is the documentation which I have referred for deploying a sample web application in AWS Beanstalk. So I'll go to the Elastic Beanstalk console. So as you can see here, I have created 2 applications. So first is the simple Tomcat web server running on a Elastic Beanstalk, and the other is a Dockerized version of the same application. So let's first check what a normal simple web application looks like. So this is the dashboard of my Beanstalk, which shows me that I have deployed a simple Tomcat web server running on a 64-bit Amazon Linux, I mean. So we can see the app here. Okay, so if I open the X-ray console, it is computing the map. It takes a while. So as you can see, the Beanstalk is attached to every app is attached to its own AWS S3 bucket. So we'll see that in a while. and for a particular application we can check its configuration. So these are the basic resources which the application is using. We can check the logs, health, monitoring. So these graphs give you a clear idea of the load and what exactly is happening. It is useful in the analysis. We can set some alarms if we want. So that's basically how to deploy a simple application. So now let's go through the Dockerized version of the same. So I have Dockerized the same application on the same Tomcat web server on a Docker image. So this is the URL. Okay, this is the page where it shows the application from the Docker image, Docker container. So now let's check Amazon S3 bucket, where I had generated some sample traffic here from the first page, which has got stored in the S3 bucket. So I'll just show the console here. So this is the bucket which was created for the Elastic Beanstalk, as you can see here. Okay, I'll not go into much into detail here. Also, I had configured CloudTrail for the activities which happen in my account. So the CloudTrail will basically give you a log of the activities that have happened, and it gets stored on the S3 bucket. So this is the trail which was generated from maybe last week or so. Most of the activities I have done in US West 1. So these are the whole logs which you can see. So yeah, this is the JSON for the respective activity. And apart from this, for my personal project demonstration, I have used VPC peering. So you can check that out in my other video. That's everything from WowFactor perspective. Thank you.